So let us start now. So this program for single linked list, and we are going to create a single linked list. Okay. So using namespace std, and then we have struct node, then we have character data and a pointer which is of type node pointer. Next, there should not be spelling mistake like capital N and small n. So it's capital N, so it should be capital N. Node pointer next, then end of structure. Then we have class, that is class SLL, single linked list. In that class, we are going to create a single node pointer node, and then have here various functions in the public section, as we are going to call these functions outside the class. So they are declared in public. Return type of create is node pointer because it is going to return a pointer of type node. So node pointer create SLL, and then it accepts a parameter which is an empty head or head with a null value. So that is a declaration of head create function, and then we have a display function void display. So it also accepts head because the linked list starts from head. So this is head, and now we are going to define these two functions. So we are going to copy the signature from here, and then we'll paste it out of the class. So the class is ended with a semicolon. So end the class with a semicolon, and then define these functions here. So initially we have a create function, and then we have display function. So we'll define display function later. Now we just have this opening and closing brackets for display, and similarly we'll have the remove this semicolon, and then opening and closing brackets for the body of create SL. So let us go for creating a temporary node, that is node pointer new node. So it's a pointer variable which will store the address of new memory location, that is new node. So new node equal to allocate memory using new. So new, and how much memory we want to allocate to store a node, that is a data part and a single pointer, that is character data and a node pointer next. So that is why it is new node. So it will allocate the memory and return the address to the new node. Now this is step 1 where we allocate memory. Now step 2 is ask user to enter the data. So we will ask user like /n enter a character, enter a character, and then user will enter the character, and then we'll assign that character to this new node arrow data. It will not go directly. We write like for a message to accept the character, we have written cout. So here we will write cin new node arrow data. After this, the next part will have a node value, null value, that is new node arrow next equal to null. So it's a capital null. It should be capital null. See, the color has been changed. So this is the create function. So we have done step 1. What is step 1? Step 1 is allocate memory. So step 1 is allocate memory. Now step 2 is assign data or store data and initially addresses null. So that is step 2. which is store data, and initially pointer will be having a null value. Store data and address initially null. Okay, after that we are going to check if the head which is passed as a parameter is having a null value. So if head is null, that means the head is not created. The first node of linked list is not available. So how to create a new node as head? So head will be having the address of new node, that is new node. And if the head is already there, so we'll display a message. What is that message? Cout. The head is already there. The head is already there. Okay. So this message we will display if this head is already created, or the first node of linked list already is created. So this is the create function. Now we'll have a call to this create function inside main. So how to call this create function? You just copy its name like this from here, and then inside main can say here so this is our program for Stingray linked list. You can say Stingray linked list, and then we have here we'll call the function which is create Stingray linked list. So we are going to pass this head here. So this head should be initially null. So we have to declare this head. So how to declare? So node pointer head and will be initially null. So head is equal to null. So that we will allocate new memory to head. So this function call is there, and this function also returns that. So when we pass this head, it is null. But when we return the head from the function create SLL, it will have an address of new node. So that new node address will be cached inside head again. You understood this? See, when we are calling the function, we are passing the head as a parameter, which is null. Then this parameter, which is null, it enters inside, it goes to this function, this small h head. And then we create a new memory, we store the data, we create a new node, and then we check if head is null, it will have the address of new node. And then we return this head. So we have not written this head from this function. So how to return? From here. So we write return head. So this return head will be cached inside that head pointer again. So see, we are catching it here, and that is why we have written head equal to create SL. So it is like an expression, like when we say now C equal to A plus B. So A plus B, A has a value, B has a value, plus is an operation. So it returns an addition. Similarly, create SLL will accept a head which is having null value, then assigns the memory location of new new memory locations address to head, and then returns that address, and that is cached inside head. So this is the first node created. After that we will display. So how to display? Again we have this display function here. So we have node pointer temp. So in the first lecture of this module 10, we have seen we start from head. So temp equal to head, and then while we don't get null value inside temp. So while temp is not equal to null, or we can only write null also. Oh, sorry, temp also, like while temp has an address. So we can write that also. So this while temp is not equal to null, what we do, we display data of these nodes. So that is out, and there is that temp arrow data. That's temp arrow data. Okay, and then temp equal to temp will go to the next node. Now as there is only one node which is head, so it will display the head and then it becomes null, because in the next part of the first node there is a null value. So it will stop after displaying or showing the value of first node. So now let us call the display function also. Just copy the signature from this definition so that it should not lead to any spelling mistake. And then we'll go here and then call display. So display with this capital H. Why capital H? Because in the main we have this capital head, that is with capital H. So we are passing this parameter with capital H. We are treating it here as small h. Okay, here it should be small h, because this is the formal parameter which is there in the function definition, and the past one is the actual parameter which we are referring. So from display function we don't need to pass any or return any value, hence return type is void. And as we does not return any value, so we don't have to catch anything here. So that is a display function. So now let us run the program. Let us see if it runs successfully. See what we get as an output, singly linked list, and it is accepting or expecting a character to enter. So I will enter the first character as H, and then I will give enter. So see, I got H displayed. Okay, so I can display it in better manner also, like a linked list, like it is starting from head. So here I will give some message like this in the display function, out, then slash n slash t, and then here, and then it is pointing to the first node, which is this. So then we'll have null here, out, null. Now let us see what we'll have. Okay, there is an error on this out. We have not used semicolon here. Okay, let us run. Okay, enter character H. We got this H as the first node, and we have just we just did some formatting so that it will look like linked list. So you can see there is an H which is there in the function, and then we can have this representation like this. So it is a single or first node in the linked list. Okay, have you understood this? Create and display? You can reply in the chat. Create and display, understood? We have seen this coding in the first lecture also. Same coding we are doing in the program. It is just for your understanding, so that you can able to implement it in your programming sessions or lab sessions. You can reply in the chat if you have understood create and display of the single linked list. So we'll go ahead now. We will see the insert function. So let us see the insert now. So first declare a function inside a class. So this class is there, class SLM. So we declare a function now here, and that is void insert. Now we are going to write void only because head is already created. Only when we create a head, then we should return that address from the function because head is the first address from which the linked list starts. So if it is changing, we should reflect it into our actual parameters. So the parameters which we use in the function are formal parameters. So we have to reflect that change of the first node's address inside head, which is the actual parameter. Hence we return the address of head from the create single linked list or create head function. Now in case of insert, we don't have to return any pointers or address value. So we have written return type as void. Now insert node. So now we want to insert the nodes. So how we want to insert? We can pass some like value also, like insert this, insert that, like that. So suppose I'm saying that insert node with some character data char, and that is suppose th. Okay, and then we'll have this node pointer head. So we always starts from head whenever we want to append a new node in the link. So this is the definition. Just copy the signature. Sorry, this is the declaration. Just copy the signature and define the function. So here we are going to define the function. So remove the semicolon, open close curly brackets for the body, and then start with the definition. So here also, in case of insert node, we are going to create a memory location, and then that is to be appended at the end of linked list. So we are going to create new nodes as a append new nodes in the linked list. So for that, we have to reach to the end of the linked list also. So how we reach to the end of linked list, that we'll see. But first we have to create the node. So the coding of creating the node is same. Allocate memory, accept a character, and then initialize, that is to null. But as we are accepting a character in the function itself, like insert node character ch, so instead of asking from the user, you can directly say new node arrow data equal to ch, like this, new node arrow data equal to ch. So now we are not taking it from user, we are taking it from the function as we are passing it from the function itself. So when we call this function insert node, we will pass a character, and that character will be assigned to the new node's data part, and its next is null. Now we want to insert this new node as a last node of the linked list. So for that, I will need a one more pointer here, that is pointer temp, which should travel to the last node. So we can take this name as last also, like last, and then this. Initially, I will say last equal to third, and then I will travel up to the last. How I will travel up to the last node? The node whose next is null. Whose next is null. So that is while last arrow next is not equal to null. Is not equal to null. So we'll travel like this. So the node whose next will be equal to null will stop there. So that is the last node. So until then, last equal to, we'll go on last equal to last arrow next. So we'll switch to the next node until the next is not having null value. So ultimately we'll reach to the last node, and then we'll append this as last arrow next equal to new node. Okay. So this is how we are appending new nodes or inserting new nodes as the last nodes of the linked list. So that is also called as append nodes in the linked list. Now we will call this function insert. So we'll copy the signature, this, and then we'll call this function here. So formal parameter will be replaced by actual parameter. So head and char ch will be replaced again by actual parameter. So suppose I want to pass e. So that is I want to insert as a new node data e. So I'm passing the character, a single character as a data, which will be inserted as a data in the second node, and then I'm calling insert node. After that, I need to display, because once it is inserted, I should be able to display it, right? So now I should get the output as H as well as E. So H is the header node and E will be the second node. So let us run now. Now, see, it is asking for the first character, so I'm entering H. So we see, initially it is only H and now it is HE. We have to just do little more formatting in the display function because the previous one line there is before E. Okay. Okay, we missed a parameter here, insertion parameter. See, so H is a head node and E is a appended node. Suppose I want to insert one more node. So that is again, we have to call the function with a next character. That is, let's just copy and call it again here. So suppose I want to say L. I want to insert L now. So it should display or add L as a new node. So run, it is asking for H only, like first node, and then C. After H, there is E is inserted, and after E, L is inserted. So we have a first node H, second is E, third is L. So head is H, and two new nodes are inserted, E and L. Okay, understood this insert function? Understood insert? Reply in the chat. Okay, good. So we'll go to search now. If you have any doubt, you can type in the chat only. Okay, I will share the programs also at the end of the module 10. So don't worry. If you have any doubt, you can ask, or you can check later also in the program. So let us go now for the search function. So here, now again go to the class, and inside a class declare the function search. That's void search node. Now this search node. Now which node you want to search? That is char. So we'll enter like which character we want to search. So that is accepted as key. Char key comma up. You have to pass the head again. So node pointer head. As it is not a global pointer or global variable, you have to pass it every time. So search node character key node pointer head. So copy this signature and define the function for searching the node. So here we have, we'll define the search now. Remove the semicolon, enter, opening, closing curly brackets, and now we have a body. So inside a body, we have this node pointer temp, and it will start from head. So temp equal to head. Like in case of array, we always start with index 0. So we check for a key. So if the key equal to array of 0, array of 1, array of 2, up to array of size minus 1. So similarly, in case of linked list, we start from head. So temp equal to head, and while temp is not equal to that. So it is like I is less than size. So while temp is not equal to null. So until then, search for a key. So how to search for a key? We are checking what if the key is equal to temp arrow data. Is it matching with the data of the first node, data of the second node? So if it is matching, what we will display? Key out. The key is found. The key is found like that. And if it is not equal, so in the else part, what we do, we just move to the next node. That is, if it is not matching with the first node, go to the next node. Temp equal to temp arrow next. So just this is right. To check whether the key to search is matching with the first node. If no, then go to the second. Check whether it's matching. If no, go to the next, and so on. And finally, if it is not matching with any node, your temp becomes equal to null. So that is the case of not found. So finally, temp's next last node's next part will have a null value. So if temp will have a null value, that is temp is equal to null. So that means the key is not found. So you can just copy this and say the key is not found like this. Okay. Now just copy the signature and call this function inside main. So see, I'm copying the signature and then call this function inside main. So after insert node, we are calling search node. Now replace these formal parameters by actual parameters and pass the key into search. Suppose I'm saying I want to search H like that. Okay. And then you're passing head. Then at the end, there is a semicolon. See, in the definition, we are using small h. So here also temp equal to should be small h. And now run. Why am I saying H? Oh, key is found many times. Message is there. Okay. So why it has come for many times?
Sir, if the key is found, then
Yeah,
we have to use break now. Sir, if key is found, then it
yeah.
would be
Key
break
is
after that.
found. There should be break, right? Otherwise, it will be on the same node and it will continue because we have written that temp equal to temp arrow next in the else part. So we are never going to the else part. We are in the if part only on the node where the key is found, and it is repeatedly displaying on the same node because we are not going to the next node. So either we should uh, type break, or that temp equal to temp arrow next should not be in the else part, so that after if we will eventually go to the next node. So it will only display one time, but it will also check for the other nodes also. It is better to write break. So now let us here type that search for key. So see out. So here we are typing search. What we are searching? We are searching H. Here we are inserting like this. We will just give the messages here like insert key. Similarly here insert L. This will be just to produce a better output. Insert L, and now we'll run. See, enter a character for head, so it is H. See, after H we have inserted E, then we have inserted L, and then we are searching for H, and the key is found. Right now, is the X present there? X is not there, right? So suppose search for X, and what output do you get? So search for X, we should get the output as not found. So let us see what output we'll get for X. So search for X. So we have called the function to search X, and then now we'll run. We have to enter the value of head H and E, L, and then we are searching for H. So key is found, and we are searching for X, and X is not found, right? So see, X is not found in the list. So this is the running of search function. It is running successfully. It is saying the key is found for the present values, and not found which are not present in the linked list. So now we'll do the modify function. So again go to the class and declare one more function which is modify. So we'll modify the value of the node now. Control C and control. So I'm just changing the name of the function. So it's modify node or update node. So the node value with which it is to be updated, that I'm going to pass, or the node which which node to be updated, that I will pass, and I will pass the head also. So just copy this signature and define. See, and then after search, define modify or update. Remove semicolon, and then there is a body of the function. Okay, and then we have update. For update node also, we have to search first. Like suppose I say I want to update H or E or L. So I have to initially search H or search E or search L. So update node initially has the logic of searching the node and then changing the value of that node, modifying the value of the node. So we will have to copy the logic of search first. So we will copy this logic of search, and then when the node is found, we will update its value. If the node is found, we will update its value. If it is not found, then we can't update, right? So we have copied the logic of search. See, temp equal to head, while temp is not equal to null. We are searching for the key to be updated, and if it is found, we will say the key is found and updated and updated. So to update, we have to change the value of the key. That is temp arrow data will be changed. So how it will be changed? By entering a new value. See out. I will ask the user to enter a new value for update. So /n/d. Enter new character to update. Okay, like this. And then that will be updated inside temp arrow data. So that is overwriting onto the existing value. This is nothing but overwriting onto the existing value. And then we'll say the key is found and updated. Okay. Actually, yes. Okay, and now we'll call this function update node, and we'll try to update any one node in the class. So replace this formal parameters by actual parameters. Now, which node we want to update? Suppose I said I want to update H. So that is the first node. So that is will be updated by M. So it is updated. H is updated by X. Okay. So I will update H by X. So I will have to pass here H, right? So I'm updating H. So it's the message I will write here. Update node H or modify H. Modify H. Okay, like this. And then I will call this function. See, now I will run. First is H, then there is E, then there is L. Now see, H is found, X is not found, and now modify H. Now as I will replace H by X, so I'm typing here X, and now it will say the key is found and updated. But I have not displayed it. I have to display the new linked list where we have the updated value of first node H by X. So for that I need to call the display function, right? So after modification of the linked list, I need to call the display function. So now I will run. So initially there is H. See, I will modify H by X. See, the value of H is modified, updated by X. Okay, you understood search and modify? Reply in the chat. Search and modify. We'll see the delete. We will see delete now, the last operation. Okay, thank you. Thank you for the replies. Now we'll see the delete operation. Now again go to the class and type here the new function, that is void delete node. And for that I should enter that which node I want to delete. So uska value and then node pointer head, like this. Then copy the signature from here, Control C, and then define the function here. Remove semicolon of declaration, create the body of the class, sorry, of the function, and then we have node pointer T and P. Now here, in case of delete node, the node to be deleted should be searched first. Okay, and now there are two cases. First is we can delete head or any other node. Suppose initially we are doing for any other node, so it will be either a middle node or last node. So for that we need two pointers. One is the current pointer, the node to be deleted, and second is the previous pointer. So we will declare here two pointers, previous and current. So previous comma current. So current pointer will always point to the node to be deleted, and previous pointer is the previous node, like so that the current node will be deleted as previous next is the current. So previous is next is current's next, and then delete current. Currently, the previous has the next node, the address of next node, that is current node, and I want to delete current node. So the address of current's node next is current's next. So that address is copied inside previous is next, so that the pointer is changed. Previous will point to the current's next node, and then we'll delete current node. So here we'll start from initially current is previous and current both are equal to previous equal to current initially, and then that is equal to head. Then we'll start with the searching, because here in delete also we have to search and then delete. So while and then current, search for current arrow data. Actually we have to start from head, so we are starting from head. The head's address is in current, so while current is not equal to null, right? So while current is not equal to null, while current is not having a null value, so we'll check if the ch, that is the character to be deleted, equal to current arrow data. So if it is equal to current arrow data, so what we'll do, previous arrow next will have the address of current arrow next, and delete current. And then if it is not equal, so previous will have, if the character is not matching with the current node's data, so previous will have the address of current, and current will move ahead. So current equal to current arrow next, so that current node will be always the next node of previous node. So previous node will be always following current node. So current will move ahead and previous will have the address of current. So you can start with here like this also, like current equal to head. Okay. So this is for deleting any other node except head. So we can, using this logic, we have not checked for head. If we want to delete head, there is a different logic. So let us see whether we can delete any other node with this. If we want to delete head also, here we have to check for head after this. Inside this if, I have to write here, if when the ch is matching with the node's data, I have to check whether current is equal to head. So if it is equal to head, what I have to do? I have to delete the head, right? So how to delete the head? So for that, there is a different logic. So if I want to delete the head, I have to write initially head equal to, initially I have to store the address of current head, like previous is equal to head, and then head equal to head arrow, head equal to head arrow next. And then I have to return the head, the new head from here, so that it will be reflected inside the actual parameter. So return head. And in case of else fault, so if the current is not equal to head, so that is else. So in this case, there will be previous, there is a previous node, so previous is next is current's next, and then delete current. Here you are deleting previous, which is the old head. Delete previous. Now, as you are deleting a head and you are going to return the value of new head, so you have to change the return type of this delete function now, and it will be node pointer. It will be now node pointer, as we are going to return the head. So you can write this here also, like instead of writing here. And once you do this, you will break, right? So either if or else, but after that if and else, when you delete the node, you have to break. So write break here. And then here, after this, you will return the head. So out of the while loop, you will return the head. So it will be either an actual head or it will be the new head, which is after deletion of old head. Okay. So this is little complex. We can repeat it again. See, we have a delete node function. Initially, we are going to only delete any other node except head. So we have the return type void. But now we have the logic for deleting head also. So we have written the return type as node pointer, because if the head is deleted, if the head is deleted, the new head should be updated into the actual parameter. So we have to return the new address of head, which is the second node now. Okay, so we have to return this address, and hence return type is node pointer. Now we have previous and current, two pointers. Current is the pointer which is the node to be deleted. So we are checking whether current is not equal to null. So we are checking for every node whether it is matching with the character or value to be deleted. If it is matching, then we are checking inside it. If this is matching, so we are checking whether it is a head node. If it is a head node, then the previous we are storing the address of current head inside previous pointer, and then we are shifting the head to the next node, that is second node, and that second node will become new head, and then we'll delete the previous old head. After that, else means the node to be deleted, current node, is not the head node. So what to do? The current node's next node, current node has a address of next node. So that current's next address is given to the previous's next. So we are initially changing the pointer, which will point to from the previous node of the current node to the next node of the current, and then will delete the current. So if there are three nodes H, E, L, and I want to delete E, so the pointer of H will have the address of L, and then we will delete E like that. So this is how to delete E or L, and you can also delete head. And then previous will have the address of current, and current will have the address of next node. So this is how previous always follow the node to be deleted, that is current node. Now let us call the function delete node, and let us see whether it is running successfully or not. So copy the signature, and here delete node, replace the parameters, formal parameters by actual parameters. Now what to be deleted? Suppose I want to delete initially uh, E. So I'm saying I want to delete E. Okay, so type here some message like this, delete E. So delete, and then E, and then write the display function, because after deletion we have to display, right, what changes are made to the link list, right? Okay, now delete, and after deleting we will again insert one more node, that is or suppose let us try with the delete first, delete E. Now E is not the head node, it is any other node, right? So let us run it, and we have missed a semicolon here, so give the semicolon and run now. Okay, so enter a character, that is H. So see, we have H, E, and L. H is found, X is not found. And now enter a character to update H, and that is X. Or I can say Z. मुझे Z से update करना. So see, now it is Z, E, L. And after that I have deleted E. So see, after deleting E, what I got? Z has the address of L, not E. So E was the node to be deleted. So I deleted the E, and before deleting E has the address of L, which I have given to Z. So previous is next. So Z is the previous node, E is the current node. So previous next has the address of E is next, that is L, and hence now Z is pointing to L, and E is deleted. Understood? Now what we do, we'll insert one more node, or we can delete Z also. Z is what? Head node, right? Z is the head. So can we delete head? Yes, we have written the logic, right, to delete head. So let us try for that. And I want to delete head, right? So I will say delete head, and my head will be Z, right? So run now. So initially my head is H, and then I'm inserting E, inserting L. So my linked list is HEL. Now I'm searching for H, it is found. I'm searching for X, not found. I'm modifying the H to Z. See. Now head has been modified and that becomes Z. So now linked list is ZEL. And then after that I have deleted E. So now Z is pointing to L, right? And now I want to delete what head? E. And I have deleted head, but there is some garbage. Why that garbage is there? Because, do you know why that garbage is there? Because we forgot one thing. What is that? We have written something from the function, but we didn't catch it. What is that? What is that? The address, right? The new head written from the function is not cached, right? So that will be passed to the head or display, right? So head equal to delete node. Similarly, head equal to delete node, right? So delete node returns the head, so we should catch it, right? So now we will run. Initially H is the head, inserted EL, and then I'm modifying H by Z, and then I have deleted E, so remaining linked list is Z and L, and then I will delete head. So Z is the head, so I'm deleting Z and C. The last node is L. So initially I have deleted E, which is the intermediate node, and now I have deleted head node, which was Z. So now I got a new head, and that is L. So the L is now head node. Understood this? Deletion of head and any other node. So we have seen two cases inside delete function. That is, case one is delete head, and case two is delete any other node. So E deleted, so E was any other node, and Z is the head node, right? So these are the operations on singly linked list: create linked list, that is create head, display linked list, insert new nodes. We can also write the logic for insert new head, right? Insert new head, insert any other node, or append nodes, the search node, or modify or update a node. So we have written the logics for search and modify the values, and then we have written the logic for delete node. So this node to be deleted can be a head node or any other node. After that, we can also insert the new nodes in the linked list as it has become very short. So we can like insert new node. So suppose I want to insert E, so that is already there. So let us insert new nodes now. Okay. So what is left is L, right? So any word from L we can make lion, right? I. So I will insert I, and I will complete lion. Okay. After that, I will insert O. So insert O. Lion. So last is N. So just call the function insert function. You can also write the insert function to insert number of nodes also using a for loop. So that is also possible. Okay, now I will call run. So initially H, then HEL, modify H by Z, then delete, deleted E, deleted Z, and C. L is left, Then I inserted I, so it becomes Li. Then I inserted O, it becomes LIO. And then I inserted N, so it becomes LION, lion, right? So we have now again 4 values in the linked list, LIO. Okay, so we have seen how to create, how to display, how to insert new nodes, how to search a node, how to modify the values, how to delete any other node or head node, and again we have inserted new nodes in the linked list. Okay, that's it for today. If you have any query, you can ask. Otherwise, we can end the session. Before ending the session, I wanted to tell you that there is a break for INSEM examination. So we can have one more lecture of module 10. This is the second lecture of module 10. In the first lecture, we have seen theory part. What is a linked organization? How it is different from sequential organization? What is dynamic data structure? Then what are the types of linked list? Single, doubly, circular. And in the second lecture, we have seen the program on singly linked list and its various operations. Now in the one more lecture, we will see doubly linked list and circular linked list. So that one more lecture will be after the INSEM examination. So your INSEM examination will be ending at on Friday. So on Friday, like there will be lecture at 4 to 6. So tell me, is it okay 4 to 6 Friday? Next lecture Friday, next Friday, 4 to 6. Reply in the chat. Next lecture will be Friday, 4 to 6 p.m. after your last paper of INSEM. Okay, so I will post the message in the WhatsApp group. If you can reply to that message. So if you have any doubt, today's code on the group. Okay. Okay, I'll share the code also. This code. Okay. So thank you. If you don't have any query, you can leave the session. Thank you for attending.